Now that Mr. Sullivan has introduced you to the converses of the parallel lines theorems and their uses, I'm going to take some time to prove them to you. I'm going to use a new type of proof called a flowchart proof. For those of you who have had a hard time seeing how the law of detachment and the law of syllogism apply to these proofs and how one statement flows into the next, these flowchart proofs may really be useful for you. Let's start by proving the converse of the alternate interior angles theorem. You'll notice down here that we have our theorem, and our hypothesis, which is what we are given, says that two lines in a transversal form alternate interior angles that are congruent. And in our figure, you will notice that we have angles 3 and 6 that are alternate interior angles. We also have our conclusion that the lines are parallel, and you will notice in our figure that we are going to be talking about lines K and H that we want to be parallel. Something else that we are going to need is a third angle to help us out over here. We're going to want to make this third angle a corresponding angle to either 3 or 6. So let's use angle 7 here. Now that we have our problem all set up, we know that angles 3 and 6 are congruent, and we need to prove that line K is parallel to line H. Let's see how these flowchart proofs work. First, as usual, we are going to start with what is given. Angle 3 is congruent to angle 6. And we are going to put all of our statements in ovals here. Some people will use boxes, some people bubbles, however you want to do it. But the arrows we are going to label with the postulate, theorem, definition, property, or reason that each bubble is true. Now our next step, we're going to be using vertical angles here. Have you noticed that we're developing patterns with all of these things? So what we're going to do is we are going to use the vertical angles theorem, and we are going to say that angle 6 is congruent to angle 7. So notice how I labeled the arrow with vertical angles theorem, and what it tells me is in its own bubble. Now I'm also seeing something else here. I'm seeing that A is congruent to B, and B is congruent to C. That's 3 terms, and so it looks like we can probably use the transitive property. And which transitive property are we using? I'm hoping you guessed the transitive property of congruence because everything's congruent. And that will tell me that angle 3 is congruent to angle 7. Can you see how these are all connecting? I needed these two statements here along with the transitive property to say this third statement. But wait a minute, angles 3 and 7 are corresponding angles. And lo and behold, we just learned the converse of the corresponding angles postulate. And that says that if the corresponding angles are congruent, then the lines that are intersected by the transversal are parallel. So we just proved that line K is parallel to line H. Does the flowchart proof help you see how things are connected better? Alright, now let's take a look at the alternate exterior angles theorem. You will notice that angles 8 and 1 are alternate exterior angles. So we are given that those alternate exterior angles are congruent. And in our figure, what we are trying to prove, that line K is parallel to line H. Sound familiar to what we just did? It should. Alright, but guess what we need in our figure to help us out? A pair of corresponding angles. So let's go ahead and get to work, and we'll start right at the beginning with the given. And we are given that angle 1 is congruent to angle 8. Have you noticed this pattern? Going over here to the figure, angles 5 and 8 are what kind of angles again? I'm hoping you're saying vertical angles, so that we can say that the vertical angles theorem says that angle 5 is congruent to angle 8. Do you see what's about to happen here? We have A is congruent to B, and B is congruent to C, and we are going to use this transitive property of congruence to say that angle 1 is congruent to angle 5. But wait a minute, what kind of angles are angles 1 and 5? They're corresponding angles. So the converse of the corresponding angles postulate is going to tell us that line K is parallel to line H. I hope that these flowchart proofs actually help you see the connections between the statements and the reasons and how they all flow together using the law of detachment and the law of syllogism.